Good morning and welcome to Astronomy 100. Today is October 4th, and we will be covering quite a few things. First of all, I know today is the last day in terms of the exam. I was hoping that you guys do not leave it to the last day. And chances are, if you see this recording later, you will have very little time left to complete your exam. So please do that as soon as possible. Okay, this is by far the most important thing that we have to complete today. And it is by far the most important assignment that we have received so far in the class. It outweighs everything else that we did. Midterms, as you guys know, have tremendous weight on your overall grade. It's actually 50% of your grade. So that means they have to be taken extremely seriously. I know I offered the review and a lot of you took advantage of it. So now we need to actually do the thing, and that is the midterm itself. So this is the last day. Hopefully you guys will complete it in time and you will not have any difficulty with your grades. The other thing also that we have this week, I know we started it last week, but it was not available then, although I made an introduction, namely the project, okay? I introduced the retrograde motion, mainly for Mars, basically, at least the topic says Mars, but it's actually other planets and actually other objects in the solar system. I mean, we have several planets. We have Mercury, Venus, Jupiter, and Saturn, and Mars, of course, in addition to Ceres, which is the dwarf planet that exists in the asteroid belt. So those are the objects that were given to you in the project, and you were supposed to calculate based on current information, or at least the last known information, at least according to that lab, when the next occurrence will be. Okay, obviously, this is the essence of science, that we, based on knowledge, we make theories, and based on those theories, we make predictions, and we go short enough to measure those predictions. And if in case they came true, then the theory still holds true. If these predictions somehow start to not be accurate, then in this case, something is not correct with our theory, provided we did the observations correctly. So this is, in a sense, what that project is. So today, actually, we have another kind of a project, or at least another project added to that, and this project is a lunar observation project. This is unlike the retrograde motion. The lunar observation requires field observation, meaning you have to go outside and look at the sky, look at the night sky, okay, for 4 weeks, one day in those 4 weeks, every Wednesday, starting not from this Wednesday, but the Wednesday after, October 13th, we will start. Then October 20th, which is the week after, we will actually go outside and actually do observations again. And October 27, we will do a third observation. And then finally, November 4th, which is a month from today, we do our final observation at night, at a given time at night, around 9 p.m., not exactly 9 p.m., around 9 p.m., okay? What we are looking for is the moon. We want to see its shape, how it looks like. We want to name the phase that the moon is based on our reading. And then we're going to, basically, when we say name, basically, is it a full moon? Is it a new moon? Is it half moon? Is it growing? Is it shrinking, gibbous, or basically waning? So those are the phases of the moon. And then we're going to locate it in the sky. I'm not asking for a exact coordinates. What I'm asking for is approximate coordinates using north, south, east, west as your indicators. Is it to the south? Is it to the east in the sky? Is it closer from the zenith, basically, is it immediately above your head or just closer to the horizon? So that's basically what you're going to tell me. If the moon is closer to the horizon, it's the horizon, or it's midway, okay, between the horizon and the zenith. The zenith is immediately above your head. When you look up, you see the moon. That's what the zenith is. Or when you look just barely coming off of the east, for example, then in this case it's on the horizon. Or it's just setting to the west, then in this case it's on the horizon. So that's basically what we're looking for in terms of positions. Here is the deal though. This coming Thursday at 9 o'clock in the morning, we will have an extra session just to talk about the projects. We don't want to do it today, because today we still have a big deal, namely the exam. And we also, because we have content that we have to cover anyway. Every week we have to have content to cover. So we have to go through the content, namely the stuff that we need to learn today. But the projects, we're going to meet on Thursday at 9 o'clock in the morning. And I'm going to go through both of them, going through the steps that you need to do. And then you complete those steps, and that's basically what needs to be done. And bring a piece of paper and a pencil. Of course, you're going to receive the invitation. The invitation will not go out until Thursday at 8 o'clock in the morning. As a matter of fact, I already scheduled them, that you will receive them an hour before the actual meeting, okay? I don't want the invitation to go buried down in the email or the messaging system, and then you start looking for it, hunting for it. You know the day, it's Thursday. You know the time, it's 9 a.m. You know at 8 o'clock, you should have received at that day an invitation. So it should not be too far from the top if it's not the top message that you have already, okay? Then we will meet and go for about an hour, potentially 2. I scheduled it for 2 hours. You don't have to stick around for 2 hours, but at least for an hour. That way we cover enough information to get you going on your projects, okay? So this is in terms of the projects. So let me first of all share the screen, and I'm going to talk a little bit more details about this stuff in here. So I'm going to go share, and it's this screen in here. Okay. Again, you're looking at the screen as I'm looking at it as a student. Last week, I introduced this project, okay? When I clicked on it, I don't know if you guys remember or not, what happened was I did not really see these details in here. I saw just the rubric, namely how it's going to be graded. But I didn't see the information in here because the project at that time was not available for us. Now it is. So I'm looking at it as a student. So now when I clicked on it, it took me to this page, and it should take you to. As I said last time, there are 2 critical links in here. One of them actually is an optional, namely the PDF file. That should help me do the report. Again, when we meet on Thursday, I'm going to go in detail about this business of PDF files and how we're going to fill it, okay? We go through the questions and try to answer most of them and make sure that you're at ease with the project, and you should be able to get going with it. All the information you need for this project are included in this link. If I click on the link again, it should take me to all the information I need. However, probably I will need to look at the book still to make sure if I am confused about some concepts, especially when what it means to be retrograde, what it means to be heliocentric model, what it means to be geocentric model, and all of the terminologies we have. At some point, you'll be graphing data based on this table. So you're going to look at the position in here of Mars. You're given the right ascension and the declination and the date, okay? Of course, you're going to have to take the date in here, and you have these 2 values, and we will see how we're going to plot these numbers in here, okay? So, and then we're going to move to the next date, the next dates, and so on and so forth. We start from July 10th, 2005, and record the data until March 20th, 2006. That's the data that we have. Somebody sat down meticulously with a telescope and monitored the position accurately of the planet Mars. From this date, from July, 10 days later, roughly 10 days later, another 10 days, another 10 days, another 10 days, all the way until March of the next year, 2006. And it told you where is the position of the planet. Remember, the right ascension is in hours, 24-hour system, and the declination is in angles from 0 to 90 degrees, basically. Okay. We're going to plot the information in here, and we're going to track it down, and we'll see that at some point the planet goes backward and then moves. Those dots in here, they are the background stars. Okay. And we're going to see the background motion. Then I explained last time also about the geocentric model and how that was able to be used to explain the position of the this retrograde motion, this what that person has looked at. We can explain it using the geocentric model, namely that the Earth is the center of the solar system. Also, the heliocentric model should explain the same thing. So if you go from the heliocentric model, namely the fact that the sun is the center of the solar system, both the Earth and Mars spin around the sun, albeit one slower than the other, Mars moving slower than the Earth. We could also explain these observations. This is observation. We can explain also the retrograde motion of how Mars appears to be moving backward against the background stars. Think of these plates in here as the background stars. The projection from your vantage point to Mars is how Mars looks like versus the background stars. Okay, based on the heliocentric model, the fact that the sun is the center of the solar system, we can actually do something better. We cannot just record observations and explain observations, like in here too, like everybody else does too. We can actually make predictions. If we know this is when, for example, Mercury did its last retrograde motion, when will it be in the future than it does its retrograde motion? So this is a prediction using a theory, and the theory is based on the heliocentric model, the fact that the sun is the center of the solar system. It turns out you can make predictions when Venus also is going to be next, and so on and so forth about all of these objects. Meaning, on that date, I could take my telescope and look for Mercury and find that it's actually doing retrograde motion. Meaning, if I look at it for a week before and a week later, or 10 days before, 10 days later, I will should see that Mercury indeed is going through a retrograde motion. The same thing for Venus and the same thing. So that means that we have a theory, which is this one. And we had a theory before, but this theory is better because we can make predictions with it. We can predict something. Okay, so that means this theory is good. So this is in a nutshell what the project is. Again, we're going to meet on this Thursday. And we're going to go through details of how that works, through how the actual project and understanding it in more depth. Okay. The other project that I mentioned earlier is the Lunar Observation Project. Now this one, the first one, you have, like I said, all the data inside that contained. You don't need to go anywhere. You can just follow the data, follow the steps, and you should be able to finish it. The difficulty with this project is its lengthiness. As you can see, there are a lot of things that I have to do. This is really what makes it hard. It's not that it's hard to do. It's a lot to do. That means I have to start it as soon as possible to be able to complete it on time. That is how difficult it is. The difficulty, the problem that we run into is the time. Meaning I have to dedicate time to do it, and complete the entire project, because as you can see, according to the rubric, the way it's going to be graded, this is a lot. Okay, it's not that it's hard conceptually. It's not that it's hard from the math point of view. All you have to do is use a formula, and I'm going to show you how you use it and add the days to the current days and then make predictions for the future. Okay, so this is the extent of the difficulty with it. And if you're not used to plotting, it may be difficult, but I'm going to show you how you plot data. Okay, all you have to do is just find the intersection of the 2 points and you have a point. Same thing, the intersection with another one, and you have a point, and you have a point. And then all you have to do is trace those points back, okay, with the pencil. Pen, or I mean, pencil is better, so that if you make a mistake, you can always fix it. Okay. But those are things that we can learn and we can do. What is hard about this project, honestly, is the length. Do not leave it to the last day when it's due, which is October 23rd, and you say, oh, you know what, okay, I have a project, let me open it and see what that project is talking about. That is a big no-no. If you do that, you really are asking for trouble, because you're not going to be able to do it, okay? You're not going to be able to finish it, I should say, unless you are 100% basically dedicated for several hours non-stop, then probably you're going to be able to do it. I mean, it's not going to take several hours, probably it's going to take 2-3 hours altogether if one probably puts his mind to it or her mind to it. But the thing with it is, it's the lengthiness, and sometimes some of those details might be skipped, and that's going to be a problem, and you will not know where you stand. Okay. So again, on Thursday, we're going to go through the difficult part of it, which is the calculations and how to make things. And then again, it's not just Thursday. I mean, if you have questions down the road or before or after, I can always basically, I'm available for that too. Okay. Okay. So this is that. Let me go back into the other project now to talk about. Remember the day of today, and I know a lot of you received messages from me today, for those who did not do the midterm, that it is due today. So you really have to focus on that. That has a lot of weight in terms of your grade. The second is the lunar observation project. What this requires is for you to go outside at night 4 nights. For 4 weeks. That means 1 night per week. Specific times, not any times. It has to be October 13th. Unless the weatherman says that October 13th is going to be a cloudy day, or October 14th is going to be cloudy day, then I try to go for October 12th. October 13th is really the day. October 12th or 14th are kind of the day, unless there is absolutely disaster in there, okay? The night is your key in there. You cannot leave it until October 15th or 16th. That's way too much, because if it's too much is too much. If it's too cloudy, okay? So we're gonna go outside, hopefully the 13th, and you're gonna record the time. Was it 9 exactly? Was it 9:17? Was it 8:47? Was it whatever the time you basically went outside in the evening? You're gonna record that time, okay? And you're gonna tell me 2 things. How does the moon look like? Is it full moon? Is it not there because it's a new moon, probably? Is it quarter moon? Or is it quarter moon? So it matters which way is pointing, which way is the bright side. Is it the bright side pointing to the east or to the west? So you really have to tell me, okay? Or is it a crescent? Whatever shape of the moon is, okay? As a matter of fact, you're going to name the phase based on those information. Is it gibbous? Is it waning? Is it full moon? Is it what is it? Crescent? Is it quarter moon? All of the different phases that we've looked at. So at this point, we'll probably have to look at the information from the book. Then October 20th. So this is Wednesday, October 30th, which is not this Wednesday, but the Wednesday after, not the day after tomorrow, but in about 10 days from today, 9 days to be more specific. Then the 20th, which is a week after, the Wednesday after, then the 27th, which is the week after, then the 4th of November, which is the last observation. These dates are hard written. You cannot skip them. These are hard-coded days. They are not to be skipped by any means. So you cannot do it alternatively on one day or the other, okay? And this is the rubric again of how it's going to be graded, okay? So this is the information in here. I'm going to open this file. Instead, I'm going to download this file. If I open it, what's his name? This browser will try to open it, and I really don't want to open it in the browser. For one thing, it takes a long time to open. So let me stop sharing and let me share now the Word document. When you have it as a Word file, let me stop sharing. I'm not sure what's happening here. Share. When you open it with Microsoft Word, it gives you this thing in here, enable editing. Do enable editing, otherwise you cannot enter anything in it. Okay, let's do that. Okay, so now I can do things to it. First thing that I need to do is put my name in it. You need to double click in there to put your name in there. Then after that, double click in the text and start answering it however you want to. Okay, this is some background information that you're going to go through and answer the questions. Again, when we meet on Thursday, we're going to go through these questions. Okay, based on this question, you're going to draw actually in here. You're going to either do a hand draw and attach the picture or append the picture using your phone or whatever camera you have. Or if you know how to use Paint well, use Paint. What I don't like, and we're not going to get credit for it, is to paste a picture from Google or some website somewhere that is not yours. Okay, that is not acceptable. You really have to do your drawing yourself, either manually or electronically, but it has to be done by you, not somebody else. It's going to be very hard to use Paint in here, but probably if you are good enough in it, it's okay. Okay, at least this part. In here, cameras do not take good pictures at night of the moon because of the background lights and the overwhelming light. So you're not going to really see well the moon with the camera unless you have a dedicated astronomy camera. Then don't try it. Okay, just draw it with hand. Again, similarly, either with hand or Paint. That's the drawing, the date and the time, the shape of the moon, how it looks like, and then you're going to name the moon face. In addition to tell me the position of it, not accurately, but approximately. What I mean by that is it to the east? Is it to the west? Is it close from the horizon? From the horizon in the west? Or is it immediately above your head on the zenith? Or somewhere in between, roughly midway between the horizon and the zenith, toward the south or toward the north, toward the east, toward the west? So that is basically what I mean by position. It's an approximate position, not exactly. So you're going to describe the position according to your observations, okay? And you're going to do the next observation and the next observation and the next observation. And then at the end, you're going to draw a conclusion based on this activity. Let me stop sharing the screen. And let me share back the screen where I was in terms of Canvas. Share. So again, this is the second project. And this should really take care at least of two projects. We still have a third project, but the third project deals with the stars. Since these two projects really are related to the solar system, One of them is the retrograde motion of the objects in the solar system, and another one related to the moon. There will be a third project related to the stars, and that one I'm going to defer it a little later when it's due, but I'm going to probably most likely post it early next week so that we have all of our projects. Here is the deal though. The Lunar project is a required project. There is no way to avoid it. In other words, you cannot not to go outside on the 13th of October, the 20th of October, the 27th of October, and the 4th of November. You really have to do that. Otherwise, you're not going to receive any marks, or you're going to receive marks less than what you could. Okay. The other two projects, namely this project, the retrograde motion of the Mars, the first project I mentioned today, or the stellarium project related to the motion of the stars, that one or the other you can choose to submit. If you think this is too long and you would want to do the stellarium, you'll do the stellarium. If you think the stellarium is too long, or you don't have a good way of getting your stellarium going for you, then you do this project, retrograde motion, okay? Third alternative is to do all three of them, but Canvas will automatically drop the lowest of these two, namely the retrograde motion or the stellarium. One of the two will be dropped. However, the lunar project observations will continue. You will actually, that will be counted, okay? So as an item of the discussion today, this is what we really need to do is, because I'm not assigning homework this week, I'm not assigning, because we have plenty of stuff to do actually. And I'm not assigning quizzes, but we will go back to those next week, okay? So from next week, we're going to revert back to those because of the fact that they really help us retain knowledge. So we need to go back into them. Because of this week, we have that thing, which is the midterm, which really has a lot of impact on your grade because it's 50% of your grade. At least all the midterms are. So what we need to do today is meet either live or recorded on Thursday to discuss the projects. This is what we need to post today, okay? Again, the invitations are already gone, but they are basically on hold until Thursday at 8 o'clock in the morning when you're going to receive the invitation. The meeting is at 9 o'clock in the morning on Thursday. This is really what we have to talk about this week, in addition to the fact that you have an exam, and then we're going to get into the project and see how they are going to be done step by step, basically. So this is in a nutshell, basically what we have for in terms of a project. So let me open the objectives for this week. I'm looking at it from the vantage point of a student. I'm going to click on this link and see what's going on, okay? This is what we have this week. What we have by far is this project that I was talking about, okay? That's exactly what this first intro was, about the projects and what we need to do about them. I know there is another thing that for some of you who did not do the midterm that should be done, and that is the midterm, which is due tonight. So if you're playing basically dangerous game, hopefully next time, at least with the project, you don't do that. But this is actually what it's a main thing, which is really the midterm. But now we have the projects. You see, now you have been exposed to all kinds of assessments in this class. And that's all there is. There is no more, okay? That's it. So you have midterms in this class, okay? And then you have quizzes, participation quizzes, questions like this one in here of the day, and then also all kinds of assignments related to this one in here. So that is the second style of assignment that you already have. You have also homework in terms of working together with people. By the way, projects also are encouraged to work with people too. So this is not an individual, just like homeworks are. So the homework you have to do, and then we have the projects. Okay, so that's it. That's how you're going to be assessed in this class. There is no other stuff that you're going to be assessed in this class. So that's it. So the last one actually that we uncovered was this one, namely the projects. Okay, and that's what the point of this one is. You will have 3 projects in this class. One of them is required. The other 2, one of them you choose to do, and the other one you may choose not to do altogether. Or if you want to, you can do all 3 of them. And they explain how you're going to be assessed by Canvas. Okay. In terms of the topic of this week, it's all about Venus, planet Venus. Okay. So this is unit 41, which is part of the next midterm. And let me put this topic into perspective so that we know where we stand in terms of everything, where we are. We went through the planet Earth as a planet, as an example of planets from the solar system, because that planet, we have access to it, we can collect data, and we learn so much about it. We don't know everything, but we know so much about it, okay? We used it as a base to study other planets or to compare it to other planets. In terms of its structure, in terms of its rocky structure, we compare it to terrestrial planets, like Venus, for example, or Mars or Mercury. Those are terrestrial objects in here. We also did an extrapolation, if you wish, when we examined the atmosphere of the planet, and we saw that it has some features that may resemble some of the features that exist in the gas giants. So we have an idea basically of what's going on, more or less. Then we ventured outside of the Earth for the first time, and we looked at the moon, which is the closest object to the Earth. And the moon has an interesting property in the fact that it revolves around the Earth. It's basically bound gravitationally to the Earth. The Earth is bound gravitationally to the sun, so by virtue of this connection, it's also bound to the sun via the Earth. Okay, so it's an object of the Earth. We understood how it came about, basically, or at least we have a theory that seemed to explain exactly where the moon came from. And then, because it's an exception, as we said last time, and then we also saw its surface and its structure and basically what's going on with it. And it gave us an understanding of some of the other objects in the solar system. Now, in terms of proximity, for objects other than the ones that are bound to the Earth, like the moon, the closest planet to the Earth, if you put them side by side, is the planet Venus. So it's very close from the Earth. And then there is actually more similarities between it and the Earth. It's almost the same size of the Earth in terms of mass. It's almost the same size in as the Earth in terms of physical size, in terms of volume. It's almost the same gravity as that of the Earth. So for a lot of reasons, Venus is similar to the Earth, except that it is not that similar. I mean, we thought initially when the planet Venus actually was discovered that maybe it has oceans. People theorize that maybe dinosaurs are still living on the planet and maybe all kinds of things. Whereas when we looked at Mars, we thought that at least maybe there are some canals in it and other things for Mars. The point being in here is that based on our understanding of the Earth, based from this vantage point that we have, which is sometimes a biased view that can be misleading, but the point in here, and the proof for it, is the fact that there are no canals actually on Mars and no dinosaurs living on Venus, so that indeed was misleading. But it's still, there are some similarities enough that we can understand a little bit about Venus, but there are differences. One of the biggest differences is the atmosphere. The atmosphere on Venus is super, super thick compared to that of the Earth. As a matter of fact, the pressure on the surface of Venus from the atmosphere alone is about 90 times more than the pressure on the Earth, 92 times to be more specific. Tremendous pressure. I mean, you cannot stand, I mean, forget about the temperature, which is by itself is a big problem. 870 Kelvin is a huge temperature, okay, on the surface. Lead will melt, let alone your yourself. You're going to evaporate actually for the most part. Then if you can stand on the surface, the pressure itself will crush you because of from the atmosphere. That's one difference. The other difference also is the composition of the atmosphere itself. Here on Earth, the atmosphere for the main part is nitrogen and oxygen. On Venus, for the main part, is actually carbon dioxide. It has traces of other elements like nitrogen and other elements, and like sulfuric acid and other elements, but for the main part, it's carbon dioxide. So, and the surface itself has no water, so we really needed to understand a little bit about this planet to see what's going on. From outside, it looks like it's a big, thick, atmospheric, basically, planet reflecting the radiation from the sun. It has a very high coefficient of reflection. Reflects for the most part, appears very bright. As a matter of fact, it's the brightest object in the night sky after the moon, and of course, during daytime, it's the sun. But after the moon, it's Venus. Okay, very bright. And usually, it's called the morning star. Some of the cultures, and actually it was believed to be a different star, the evening star, because sometimes it appears in the evening, sometimes it appears in the morning, but then it turns out to be just one star. It's the same thing. It's the same star, which is Venus in this case. On the surface, it's really, really baked by the temperature and also the acid that rains on this planet in here. And it's extreme high temperatures where the Russians had a couple of landers, and the lander there lasted for about 90 minutes, and then basically it melted and could not survive anymore, okay? So the point being in here is the surface is extremely hot, extremely hostile, and the geology of it looks, at least the topology of it looks a little bit not too different from the Earth, except that these are not oceans. These are lowlands, okay? And these are actually highlands. You look at Venus, most of the markings in here, most of the land markings in here are named after women. Famous women, whether real women or from history or from mythology, with the exception of this Maxwell Mounts in here in the near the pole. How did we get this picture in here? We used radar technology, basically radio waves that penetrate the thick atmosphere to give us reflections of that, basically based on the time it takes for them to go and bounce back. We get the information about the topology, the highlands and lowlands and so on and so forth, okay? In terms of structure, because of a similar size to Earth, we theorize, again, we don't really have exact data on it. As a matter of fact, we don't really know for 100% sure about the Earth. We have a lot of data to support our model for the Earth. Based on the comparison with the Earth, it looks like it has also a crust, just like that of the Earth, with the exception that the crust is just one shell. And like that of the Earth, which is made of plates. And the movement of the plate tectonics on the Earth plays a major role in the cycle of the carbon, because the carbon is taken with the rock and basically recycled underneath, and that keeps the carbon in check on the Earth. Because of the fact that the crust of Venus is just basically one thick crust, it does not recycle oxygen. There is always outputting of carbon dioxide, not oxygen. Did I say oxygen? Carbon dioxide. Carbon, basically, because of this lack of this activity. So there is always carbon dioxide in the atmosphere. So this is what we think happened, okay, according to some recent studies. They date this one as back as 150 to 450 million years ago, that the surface of the planet was no different than that of the Earth. As a matter of fact, the temperature was slightly higher on the planet than the Earth because of proximity from the sun. At some point, for some reason, maybe triggered by some sort of an asteroid that hit the planet or something like that, volcanoes erupted in the planet. And volcanoes, what they do, the outgoing gassing basically mainly of carbon dioxide that was released in the atmosphere is a greenhouse gas in the sense that it traps the heat on the planet. So radiation comes from the sun, and the heat is trapped in the form of infrared radiation. That evaporated whatever water, with the shallow water that exists on the planet, and the water that evaporated actually that became vapor is also a greenhouse effect. So it added to the problem. It did not really help. So it made the planet even hotter, meaning more evaporation is happening until it lost all of its water. Because of the extreme heat that was on the planet, the molecules of the H2O really dissociated and broke down into oxygen and hydrogen. Hydrogen being super light with that much heat and on the planet, of course, gained the huge kinetic energy, and because of its light weight, it escaped the planet. So the planet basically, and the oxygen was recycled with the carbon and other elements in there. So now the planet basically is really very, very hostile in terms of the any kind of possibility of life forms whatsoever. The problem with it is actually right now it reached equilibrium. It's no longer in a kind of a greenhouse runaway effect, but that happened in the past. Now it's really in a stable condition where most of the radiation is actually reflected outside. Whatever little penetrates, because if you happen to look up in the sky of the planets, you will see that it's hazy. It's like the evening in here. It's very, very hazy. You cannot see anything. You cannot see the sun. Okay, so this is part of the conditions on that planet and how it evolved to this point. One of the problems, or one of the properties of the planet, it's actually its peculiar motion around the sun. It behaves like most of the planets. It moves around the sun in the same direction, which is mainly counterclockwise. But it spins actually backward. It spins clockwise. While it's rotating, it rotates clockwise, while it's revolving around the sun counterclockwise, which means that the sun does not rise in the east if you are standing on the planet. It rises from the west and sets in the east. That's basically what we know about the planet. The other problem also, it spins extremely slow around its own axis. The rotation takes 243 days. A day on Venus is 243 days. 243 is what 4 months? Yeah. Yeah, it's about 4 months or so. No, actually 8 months. Okay. Divided by 30. Yeah, it's about 8 months. So it's extremely slow when it spins around its axis. As a matter of fact, it's so slow. Let me tell you why this is critical in here, this problem. I mean, what kind of implications it can have. In terms of structure, it's the same mass, the same size for all practical purposes with the Earth. So in terms of internal structure, it should be no different than the Earth, other than the fact that the crust, in terms of geology, is just one big block. Basically, there is no plate tectonics or anything that we can think of. And when there is too much heat, the way that the plant, because of the inside, there's too much heat, the way that the basically heat escapes is through volcanoes, volcanic activities. Okay. And of course, there is a mantle and there is a core, and the core has two components in it: the solid core, which is iron and nickel, and the outer core, which is the molten, basically iron and nickel. Those are metals, and metals, if they're basically drawn to a motion, they have electrons that can cause electricity, and electricity that can drive a magnetic field. Because of the extreme slow motion of the planet around its axis, there is not enough current, at least, to generate a magnetic field. That's why the planet is not protected, shielded by a magnetic field. So the radiation from the fast-moving particles, they go through straight through, okay? Not deflected whatsoever by a magnetic field. So this is part of the things that we know about the planet. This is some of the stuff that we learned about the planet. And this is not in lieu of you guys going to go and read about the unit. It's a short unit, 10 pages or so. So hopefully you guys can go through them and see the units in detail. And if you have any questions, please let me know. Let me go back just to make sure that I didn't miss anything. So again, this is the week review from the week before. This is the discussion that is coming from today, which is just that item that has to do with us meeting on Thursday at 9 a.m. And I'm going to post the recording in here. And the Lunar Observation Project, in addition to the Mars retrograde motion. I called it Mars in here in the title, but mind you that there are more than Mars basically studied in this one. Actually, we talk about, I mean, the main thing is Mars, but we actually predict for Mercury, for Venus, for Mars also. We make predictions for Mars and Jupiter and Saturn, in addition to Ceres, which is a dwarf planet that exists between Mars and Jupiter. So this is in a nutshell what we have this week. Let me stop sharing. And if you are watching this one recorded, the recording is going to come out a little later. So hopefully you got my message earlier in the day about missing the exam if you did not do it already. And also you will receive an invitation this coming Thursday at 8 o'clock in the morning for the meeting being at 9 o'clock in the morning. Okay, sounds good. We'll stop the recording.